Hello again, everybody. I found this schematic actually for BMW. This is from the old Chilton books that was used, and I came back to this because I think this is the best layout of a schematic and components that I've seen. Much better than the schematics today, and it's very simplified for beginners. And what I like about it, and you'll see, first of all, they give you all the symbols, and we went over the symbols. I did it before in another video, so I don't want to go over it again. But you'll see all these symbols, and they tell you what it is: the bulbs, the resistors, obviously, types of switches, and types of fuses that we went over. Now, what I like about this over here is they give you the colors of the wires and the abbreviations, what they stand for. On top of that, they show you every little element. So they show you over here power condition, hot at all times or hot in run or start. Then they have here splice or connector when this is a node, a connection of 2 or 3 wires. Then they show you the component names. This is a capacitor. These are spark plugs. Then they show you terminal numbers. See, these are like the pin numbers on this PCM, which we'll do later on the computer board. Also, the brackets, the model option over here. They tell you. They tell you also the ground, the physical grounds, the systems, where it is, where it's going to, or where it's coming from, and the wire color, like we just discussed. So I think this is a good preparation. This one, to really understand what the numbers mean and what the symbols mean. So if you could pause, you could look at this. We're going to go to another schematic and you'll see what I'm referring to. Again, Chilton, I love their layout. It's so easy to see, compact, not so many lines running around all over the place. Again, but this is an older version. Today you have more lines because you have more computers, more connections. So let's start with the basic with a fuel pump. Okay, fuel pump. One thing always should always come to you. A relay. A relay controls the fuel pump. Another thing should come to your mind is the computer. The computer has control over one side of the relay. So 3 things: fuel pump, a relay, a computer. Okay, and a fuel pump, obviously. Which I just said, obviously. Anyway, let's start. So, where do you start? Which has to be activated first? Which side has to be activated first? Right here, B. B is a continuation to another part of a schematic. So if you want to find the other part of the schematic, you have to look for B. If you want to look for the other part of this schematic, you have to look for E. Okay, so it saves lines on the paper and it makes it less confusing. So from B, from that point, which is obviously the battery or the power distribution, this is the first one that has to be ignited, so to say. So current flows. Remember, voltage doesn't flow. Current flows. Now another point to be made. These terminals, these pins that are in the relay, 85, this should be 86, 87 and 30. They should sound familiar. That's because it's a very popular relay that's used in GMs all over with these numbers. So once you memorize the numbers, 86, 85, then you know 86, 85 is the coil part of it. The switch part of it is 30, 87. You want to jump this 30, 87 standard. Okay, you'll find it a lot of times. So current flows from here, right? Goes over here, goes into this terminal pin 87 of the relay, comes actually of 4, because this whole thing is referred to as a fuel pump relay. It comes out of this one, the pin 4 connector. It comes at the terminal that it goes into. It goes over here. And it goes into a brown-green wire, brown with a green stripe. So here we go here. Now, this gets a little tricky. We know one side is usually plus. We don't see the battery here. We don't see the power source. But we know that this one is B plus, 12 volts. 12 volts. Therefore, if this side is 12 volts, what would this side be? This has to be ground. Now, sometimes we get a physical ground. But look at this, what I've been saying all along. All along I've been saying this. Transistors control the timing. So therefore, this, as I made videos on my channel, Joe Electronic Schematics for Auto, this is a transistor. In order to ignite, to trigger this transistor, we have to ignite, or we have to give a voltage, 0.7 volts. This is called the base, and the one that goes to the ground is called the emitter. This has to be, it's called NPN. This base over here has to be 0.7 volts more positive than this one going to ground. So if the base is 0.7, the ground will be 0. Anywhere from 0.7, 0.6. Okay, like a diode. Diodes are silicon and germanium, but to forward bias them in order to conduct, it has to be, the base has to be, or the anode has to be more positive than the cathode. I don't want to get too complicated, lose the audience, but anyway, that's what we need. Once this happens, this acts like a switch. Now current can flow, guess where? To ground. So this is on and off, and it's triggered by something, probably the computer triggering the base. Nice. This capacitor here charges to the 12 volts. When this works or is conductive, as we say, what does conductive mean? That current flows through it. When does it conduct? When base and emitter are forward bias. 0.7 volts here, more positive than this one. It saturates the transistor, it's called NPN. Now this capacitor that's charged will discharge across the transistor from one plate to the other plate. That's not so important. But anyway, main point is we're not using a physical ground for this part of it. We're using a computer to tell a transistor on and off. This is what I've been saying. Keep that thought. Next, what happens if this is turned on, the first part of the equation, then this has to be turned on, right? So current can now flow from here, right, through here, out pin 2, out of the connectors, which are signified by these numbers, into 15, into power distribution box, into a fuse, going into 15, going to a fuse, F18, rated at 15 amps, coming out the box at 16, and finally going to the fuel pump, right, and finally going to ground. So, we're left with a couple of things. 12 volts here. How much do we have here? Usually if this would go to ground, we have the full 12 volts across here. We have 0 volts. Now, this is acting as a switch. Since this is acting as a switch saturated, I assume it's 0.2, a very low voltage, 0.2, 0.3 volts to ground. So you could, in my opinion, you could say it's almost 0 volts, okay? So if this is 0 volts over here, that means 12 volts here, and 0 volts means we lost all of the 12 volts across here. Again, this is saturated, acting like a switch. Transistor can act as an amplifier. You'll see on the channel if you look up my channel. Anyway, regardless of that point, 12 volts here, 12 volts here. Why? This is just a switch. We don't lose any voltage. Going into the wire, 12 volts into the fuse. Why? This is just a straight wire. Coming out the fuse, how much? 12 volts. Why? Again, no voltage loss across a fuse. And finally, how much at the fuel pump? 12 volts. How much over here at the other side? Going to physical ground? 0 volts. It's not working, right? If it's not working, let's say fuel pump doesn't come on, right? A problem. Well, 90% of the people would say, let's jump it. Let's jump which one? Let's jump 30 to 87. Let's look for that relay. Look at those terminals, which I've showed you a couple of times. Let's jump it. Fine. Fuel pump comes on. What does that tell you? You know what that tells me? That tells me that the fuse is good, the fuel pump is good, and B plus is coming here. Does it tell me that the switch is good? Not so fast. Maybe the switch might be bad, but also maybe what's needed to turn on the switch is this. So maybe the relay is bad by not turning it on. Maybe the transistor is bad by not being turned on to allow this to be turned on. Maybe the signal from the computer to turn this on is bad, right? To turn this on. So there's a lot of variables still left once you jump this. Understand? Could be that the switch inside is really bad. Imagine changing this because you think the relay is bad, and guess what? Now the computer or this transistor is bad. So what are you left with? You have to. What I would do is I'll first go 12 volts over here, right? Then I want to see my voltage over here. I should get like, let's say, almost to ground when this is conducting. Okay, zero point 0.2 volts, whatever, something close to ground level. Then I would continue to this one. I could start off by saying, okay, let me go over here. First one over here, 12 volts. Right? 12 volts here, what does it tell me? 12 volts tells me off the bat, this is closed. And why is this closed? Because this is activated. Why is this activated? Because the transistor is working. Why is the transistor working? Because the computer made it active. So in theory, I could go to this part, but going to the fuel pump, you don't want to go to the fuel tank. No access. So you want to go over here. Going over here, that's the best point actually. Like I always say, go over here, 12 volts. This is working. Why is this working? Because this is working. Why is this working? Because this is working. Why is this working? Because the computer is working. Right? That's how you approach it. Next one, I will go through this very fast. Like I said, I love the layout. Look at this, ignition coils. How many cylinders in this engine? 1, 2, 3, 4, 5, 6. Boom, off the bat. Where's B plus coming from? It doesn't tell you, but you see. This is the primary, this is secondary. The secondary has much more turns, thousands of turns than the primary. Really, a transformer, you put AC through it, from primary to secondary. However, because that's a changing field that you need AC. However, this is DC, so we make it change by triggering it on and off by the computer. Here again, look at the computer. What do we have here? Transistors. What should come to your mind? A transistor is being turned on and off. What does it turn on and off? The ignition coil. This is the primary, where the green is, and this is the secondary, going to a little, I don't know if you can see it, to a little spark plug. Once this is cut off by the computer, means it's not conducting, guess what happens? You get a collapsing field, right? You get that spike that goes into the spark plug, the arc, they call it. So that's why I like this one. Anyway, go to my channel, Joe Electronic Schematics for Auto, and I'll have to make another one, and I'm going to continue with the layout and really teach you how to go over the powertrain control module, which is a very important one. With this layout, I think it'll really simplify, it'll really make you understand it better. Thanks.